Hey guys, I hope you guys are having a good day. Uh, Throughout the week, we went over complementary angles, supplementary angles, and today we're going to finish off with vertical angles. Now, vertical angles, the first thing you need to know is what are they? Well, vertical angles are pairs of opposite angles made by intersecting lines. So if we look at the picture here, we'll notice that 1 and 2 are vertical angles because they are opposite to each other. And then the two intersecting lines, we could go ahead and name them. So let's call this one M, and then let's call this one N. So M and N intersect, and they make opposite angles. One pair of them is 1 and 2, and then the other pair would be 3 and 4. Now, what is important about them is the following. So the vertical angle theorem. And this is the part that we're going to be focusing on. If two angles are vertical, then they are congruent. So what does congruent mean? Congruent means the following. It means that there is a sequence of rigid motions that map one onto the other. Now, rigid motions could be reflections, translations, and rotations. Now, in this case, the easiest way to map one onto the other is to go ahead and use reflection. So if we think about it, we can go ahead and how can we map 3 onto 4? Well, the easiest way, like I said, is to go ahead and reflect it through this red line that we have here. So if I go ahead and reflect 3 onto that red line, then I'll have this, right? It's going to go ahead and overlap with the other one. So that means that they are equal to each other, or in other words, that they are congruent because there's a sequence of rigid motions that map one to the other. In this case, it's only one rigid motion, which would be reflection. All right. So now, why is this important? This is important because what follows after that is that because they are congruent, this tells us that they must have the same angle measure. So angles that are congruent have the same angle measure. In other words, they have the same number of degrees. So let's say, for example, here on the bottom one, let's say that this one is 90 degrees. Let's actually make that in red. So let's first color in the line. This one's 90 degrees. Now, if I go ahead and reflect it through, let's say, the red line that we have here, I reflect it through x equal to 3, then remember, if these were points, then this point will be a distance of 2 away on the opposite side. So this would be 1, 2. So these will be my new points. And then for the top one as well. And basically, I would have the angle that I have on the right, have it overlap with the one on the half on the left. So that means that the angle on the left must also be equal to 90 degrees. So in other words, they are equal to each other. So hope this is making sense. If it's not, hopefully the next examples would make it clear for you. So let's go over some examples. So number 1, we have to identify first what are the vertical angles. So one way that we can go ahead and do that is by first identifying the 2 lines that I want to focus on. If you notice, we have 3 different lines here. So we have M, we have N, and then let's call this one P. So what 2 lines should I be using? Well, the 2 lines that make the 2 angles that I'm interested in. So in this case, the 2 lines that I want to focus on is going to be M, and then the second one is going to be N. So I'm not worried about P because P has nothing to do with the angles that I'm focusing on. So now, because this angle is opposite or vertical to this angle, then by the vertical angle theorem, we know that they must be congruent, or in other words, that they must be equal to each other. So we're going to go ahead and do that. So this is the same thing as 29 is equal to 3x plus 2. And then to solve this, we subtract 2 from both sides. That gives us 27 is equal to 3x. We divide by 3. Our final answer is 9 is equal to x. Now, how can I check that this is right? Well, if this is 29, then this side must also be 29. Because, like I said, they have to have the same angle measure. So let's go ahead and substitute my 9 for my x that I have here. So 3 times 9, that's 27, and then plus 2, that will be 29. So yes, it does check out. Both of the angles are equal to 29, just as I expected them to be. So let's go over another example. Number 2. Well, like I said, we first have to identify what lines I want to focus on. Now in this case, it's made out of 2 triangles. So we have a triangle on the left and we have a triangle on the right. But triangles are also made up of lines or line segments. And in this case, the 2 line segments that I'm interested in are these 2. Now, these 2, now remember, when 2 lines intersect, there are 2 pairs of angles. So the first pair is this one is equal to that one, which I'm not really interested in because that doesn't give me anything for my value of x. But I am interested in the second pair. The second pair is going to be 52 and 2 plus 5x. Now, try to do it by yourself. So what should be true about both of those angles? Should they add up to 90? Should they add up to 180? Should they be equal to each other? Now, in this case, because they're opposite to each other, we know that we can go ahead and do a reflection that will make this 52 overlap with this other angle, making them equal to each other. So let's go ahead and do that. We have 2 plus 5x is equal to 52. So we subtract 2 from both sides. This gives us 5x is equal to 50. We divide by 5. X is equal to 10. Now, how do I know that this is right? Again, I can just substitute the 10 that I got into the equation. So this equation should be equal to 52 for them to be equal to each other. So 5 times 10, that's 50. 50 plus 2, that's 52. So it does check out. So I went ahead and checked my answer. So this is right. And the previous one I also checked. So both of them are correct. Now, the last example that I want to go over is the case where you have the angle. So same thing that we have for example number 2, except that in this case, we are focusing on the angles that are inside the triangle. But in reality, this is the same thing, same process. Now, the reason why I wanted to go over this example in particular is because later on we're going to go over interior angles or the sum triangle theorem. Alright, so again, there are 2 pairs. It's going to be this one is equal to that one, which, like I said, doesn't really help me much, but it's also good to point it out. Now, the second pair is the one that I want to focus on. So this one has to be equal to this one. Alright, so let's go ahead and do that. This is going to be 4x plus 1 is equal to 2x plus 9. Now that we have this, now notice that this one's also a little bit different because we have two x's. We have x's on both sides. So what we have to do is to go ahead and put x's on one side and then put our numbers on the other side. So we want to combine like terms basically, but we first have to move them to the side that they belong to. So I'm going to use a strategy. So my strategy first is to move my 2x to this side. Now to do that, I have to make this one go away. So to make this one go away, I have to use inverse operations, or in other words, use opposites. So what should I write down? You try to do it. What I should write down is, in this case, minus 2x. Minus 2x, because that cancels this one out. and then there's going to be 2x plus 1 is equal to 9. Now that I have 2x plus 1 is equal to 9, that's basically just a two-step equation. So in other words, all I have to do is subtract by 1 and then divide by 2 to get my answer for x. The key part here is to move the 2x to the other side, but you can't just go ahead and add 2 plus 4 and I give you 6. You can't do that because that unbalances the equation. You have to go ahead and use inverse operations. So in other words, you have to subtract 2x from both sides because that makes it leveled. If you subtract 2x from one side, you should do that to the other side as well. All right, so let's go over here and solve this. Minus 1 is going to be 8 is equal to 2x. Divide by 2, x is equal to 4. Now, in the previous one, we went ahead and checked whether we got this right or wrong. I mean, whether we got it right or wrong, just checking our answer. So I'm going to go ahead and do that. But in this case, I have to do it for both of them. So let's do the first one. So you have 4 times 4, because we're taking the place of x, is now going to be 4. And then plus 1. And then my second equation is 2 times 4 plus 9. So doing this on math, we have 17 on this side, and then there's going to be 8 plus 9, and this is correct. 17 is equal to 17. That is correct. Just as expected, this was the correct answer. Now, you don't always have to do this part that I have here, but I like doing it because it helps me check whether I got the right answer. You're not always going to be be given multiple choice tests. Sometimes you have to figure out whether your answer makes sense or not. So to do that, you just have to go ahead and substitute into the original one.